The photocurrent increases linearly with intensity of incident light. The photocurrent is directly proportional to number of photoelectrons emitted per second. This implies that number of photoelectrons emitted per second is directly proportional to intensity of incident radiation. Now we will see the effect of potential on photoelectric current. If we vary the positive potential of plate A gradually, it is found that photoelectric current increases with increase in accelerating, that is positive potential. Now you can see the plot between photocurrent and collector plate potential. If we increase the accelerating potential of plate A further, the photocurrent does not increase. This maximum value of photoelectric current is called saturation current. The minimum negative or retarding potential V0 given to plate A, for which the photocurrent stops or becomes zero, is called cutoff or stopping potential. All the photocurrents emitted from the metal do not have same energy. The photoelectric current is zero when the stopping potential is sufficient to repel even the most energetic photoelectron with the maximum kinetic energy, that is Kmax, so that Kmax equals to EV0. Now we will see the effect of intensity of light on photocurrents. We will now repeat the experiment with incident radiation of same frequency but of higher intensity, that is I2 and I3, such that I3 is greater than I2 is greater than I1. We note that saturation current are not found to be higher values. Here in this plot you can see the variation of photocurrent with collector plate potential for different intensities of incident radiation. Incident radiation of same frequency but of higher intensity. This shows that more electrons are being emitted per second proportional to intensity of incident radiation, but the stopping potential remains the same as that for incident radiation of intensity I1 as shown graphically. For the given frequency of incident radiation, the stopping potential is independent of its intensity. In other words, the maximum kinetic energy of photoelectrons depends on the light source and the emitter plate material, but is independent of intensity of incident radiations.